Today I'm going to be going over how to use Git and then GitHub, which is an online Git repository um, service that I'm sure a lot of you are familiar with or at least have heard of. I'm going to go through the different ways of creating a repository, how to collaborate on a repository, the different type of actions you do involving all of the code and the files and things like that. And then we'll look at some of the features that are a part of GitHub that are useful for projects, be it your own projects or ones you're working on with a team. So to get started, one recommendation that I have, it's not necessary to use Git just because Git itself is a command line application that you can use by just installing it there. But personally, I think that a great way to learn GitHub is using GitHub Desktop, which is an application that GitHub offers to manage some of the Git state within your local device and be able to manage it in a way that's a little bit easier than the raw command line side of Git. So you can go to desktop.github.com, or I'm sure there's a link on just github.com for that to download it and install it. I'll let everybody get started on that here if that's something that you're interested in. But then in the meantime, I'm going to go over the different ways of creating a repository. There are more or less three basic ways that I know of that create a repository. Cloning a repository from the internet, which means you'll have made it online first. You can create a repository on your hard drive here through the GitHub desktop application. Or if you've already created a repository on your computer, you can find it using the desktop application, and then it will know about it and be able to work with it. So to start with, we'll look at cloning a repository from the internet, because I think that this is how a lot of people use GitHub and is a good way to get started. So once you're in GitHub and you're signed in, up in the top right, there's going to be a plus button. You can click on that and then click on New Repository, and then go ahead and pick a name for your repository. So I'll just call this Demo Web Dev. The names for repository are generally constrained by just things like no spaces. It looks like it'll even let you give it spaces, but it'll put a hyphen in it for you. So normally I like to name repositories lowercase, hyphenated, that kind of thing. You can give it a description if you like and choose if you want it to be public or private. There are some restrictions for a private repository on GitHub, but in most cases it's okay with either. You just miss out on some of the extra GitHub features that we'll take a look at later. And then it'll give you some options for initializing your repository with some files in it. If you're going to create a repository in general, it's usually a good idea to have a README and a gitignore. But if you're creating the repository online for the first time, then go ahead and check one or both of these. If you have already created the repository locally, then you're not going to want to do this because then you might have trouble merging them. But since we haven't created a repository anywhere else, then we'll go ahead and get started right here like this. It does not want me to go ahead without choosing a template, so let's just go with Java. Okay. Let's see if it has one. Let's see what all of these are. Well, a lot of these look like not JavaScript, so let's just pick a fun one like JBoss and create the repository. So now we have a repository here. You'll see it if you go to my profile and click on repositories, it'll show up right away. So then what you can do now with this is click on the green code button, and then depending on how you've set up your GitHub, you'll be able to clone it using either HTTPS if you are signing in with a username and password, or SSH if you're signing in with a SSH key. Nowadays, GitHub, I think, recommends, if not enforces, having an SSH key, so you'll probably want to do it with SSH if possible. So then you go ahead and copy this, and then let's go to a folder where we can find some of these files. Let me see if I remember my file structure on this device. Let's just make a new folder. and then we're gonna call git clone, and then the name of that repository that we copied there. And it looks like oh, you know what? I haven't set up this computer with the SSH key. Let me see if I have HTTP authentication enabled on my account here. If not, take my word for it that this would work. There we go, perfect. So if we go in here now to the repository, the name is going to be the same as the name of the repo for the folder it makes. We'll see it has the files in here. So that's one way of making a repository. Another way is you can just make a new folder. Let's call this we'll call it demo 2. And then we'll go into that. We can run git init, which initializes a Git repository in here. Let's add a file now. So we can just let's send some data into it. So now we have a file here that has some data in it, and then we'll be able to add the file to the repository. So what you can do for that is you can either call you write git add and then the name of all the files you want to add. So if there's more than one file here, like if there was file 2.txt, we could add that as well. But a lot of the time you just want to add every file that you have changed or added that's new to the repository. So then you can type git add dot, and that matches every file in the repository. I'm pretty sure this is just a regular expression. It might be a glob actually. It's some sort of syntax like that, but in general you'll either just type dot to add everything, or the names of individual files if you want to add specific ones. So now the file's been added to the list of files that this repository cares about. So we can see what the status of them all is by running git status. So you can see we're on branch master, which is the default name of the branch. We can get into branches in a bit here. And it says there's a new file, file.txt. So right now the repository knows about the file, but not what to do with it, and it hasn't saved any of it to the repository itself. So what we're going to do is run git commit, and when you do that, then everything that's staged in here that's set to be committed, it'll take that and it'll commit it with a message based on oh my. Okay, so it looks like VS Code is my default text editor that the terminal wants to use. So we'll put our commit message here. So we'll just call this initial commit. And then we'll save it and close this, and we'll see that it has committed it, initial commit. And if we run git log, then we can see the commit, the time, and the message here. So now we have a commit in this repository, but we haven't connected it to anything online yet on GitHub. So to do that, we'll go and make a new repository again. And so this time, because we already have an existing repository, we're going to name a new repository the same thing as our local repository, and we're not going to initialize anything. So now we have a new repo here. And so here you can see the instructions for how we might create it. And we've already done some of these. We've created the file, we've committed it. So now we want to run the git remote add command. And so what this does is it sets up a relationship between the local repository that we just created and the GitHub repository that has the same name as it. That relationship is called remote. So the remote repository for this local repository is on GitHub at this address. So we're going to run this and set that. And now we're going to push our changes from our local to the remote. It looks like we need to add a little bit more to the command. So we're going to push to the remote named origin. That's right. So the remote system, you can give a name to each remote, and origin is usually the name of them all, the name of the default one. Source ref spec main does not match any. Interesting. Okay, so it might be because the branch is master. Yeah, so when you initialize a repository in GitHub, I think it usually uses the name main for the primary branch, but I think Git uses master for that. So just make sure you're using master or main, whichever is correct. You'll be able to tell by looking at the repository, because we saw before in the log or in the status it says on branch master. But then here we can also see the name of the branch here is master. But if we go back to the one we initialized on GitHub, we can see it was main. That's just a syntactic difference between the two services, what they name the default branch. And then the third way that you might want to create a repository is just by clicking create new repository on your hard drive. This one, pretty simple. Not much to go over really, so I'll just skip that. And so then, now that we've got the repository set up, you'll be able to go about making changes to all the files in this system. The way that Git organizes all of these files, everything in the repository, is more or less that it doesn't. It doesn't care what any of the files are, what type of files, how big they are, anything like that. All it knows is that it lives in this repository, and anything that's in that same folder as the repository itself should go in the repository as long as you Git add it when you commit. So a lot of times that is not going to be exactly what you want. So let's go back to the demo web dev and we'll take a look at what a git ignore is. So we initialized the repo with a git ignore. So let's take a look at the, I wonder if I have less installed on here. No. Okay, cool. So this is a git ignore file, and what it does is it tells Git to ignore everything that has a name like this. I picked JBoss because the name sounded cool, but I don't really know what it is. But you can see from all the things here, these are the different files that it's telling Git to ignore. The way that these asterisks work is there are wildcards. A single wildcard means just the name of a file or something like that. So you can see star.log means ignore any file that ends in .log. Just a star on the end means ignore any file in this directory. And if there's 2 stars here, it means ignore any directories, 1 or more, or 0 or more even, I think, here. So that's basically saying anything that's inside of this JBoss server minimal temp folder, ignore it. So if you have something like production code, some sort of secret like a authentication key or something like that, you definitely want to ignore the file that that lives in. And you'll want to ignore any large files that don't play nice with Git. Usually that means images, binaries, zip files, that kind of thing. But Git will still work with them. Git does it stores files and it logs changes based on raw text. So that works great for a file that's made in raw text, something like a .js or a .html, where you've written it and every line is more or less what it says. Compare that to something like a .word file or .doc, I guess. Anything like that that has formatting and wrapping on it and that kind of thing. Git isn't going to be as good with, because it's not going to have the same properties as a text file where changing something changes only 1 or 2 things around it. A lot of the time you'll have changes all over a file just from changing 1 or 2 things about it. So Git is usually best used with code and those type of things, but there's also no reason that you can't use it for something like pictures. It's just that because of how Git stores its history and all that kind of thing, it's going to take up a lot of space, so it's not really recommended. So from here, now that we've got our repo initialized and set up, let's start actually working on some code. So one more thing that I wanted to demonstrate was if we do something like npx create React app web dev React, then this is just a way to create a React application, which is a JavaScript library. It's going to create that repository and install a bunch of things in it. Hopefully it doesn't take too long, but part of what it does with that is it initializes a Git repository automatically, and then you just have to push it to GitHub the same as we set up before. And I'm going to do that using the GitHub desktop application just to show how that works, because it's potentially a little bit easier than setting it up using the web browser. But while we wait for this install to happen, does anybody have any questions so far? All right. I take it then that everybody's following along, making a bunch of empty or close to empty repositories, or just watching and learning. As usual, this is being recorded and will be posted on our YouTube channel once it's been once this meeting's over. And there will be, of course, lots of people who know about Git available to ask questions of in our Discord if you have any questions after the fact. Looks like it's making progress on the install here. I mostly just want to have files in here that look like code that I can pretend I'm collaborating with. This will be the part of the video where we play the elevator music. Here we go. I might have lied. I thought we were close to done.
Did we get copyright claimed if we put the Jeopardy theme song in there?
I think so, but I doubt we make much money off our videos, so who's really winning there?
We've decided to monetize the WebDev UW YouTube channel.
Exactly. So let's just go into this folder here now, and if we look at git log, we can see it's already been initialized by create React app. And so now, if we wanted to, we could push it to GitHub using the same steps as before, where we make a new repo with the same name. But here, we'll use the GitHub app. We'll click Add an existing repository from my hard drive. Let's get this path, and we'll paste it in there so I don't have to worry about doxing my file paths. And now we see the repo here. The last thing we'll need to do is click Publish Repository, and that'll create the repo. You can choose if you want it private or not, and then it'll send it straight to GitHub. So now we'll see what it looks like when you've got the repository loaded in here. As you can see on the left, it says no changed files. In the history, we can see the log and all the different files that were committed there. But if we want to work on this code, then let's just pull it up in VS Code and take a look at, say, app.js. So in here, this looks like your typical Create React App file. So let's change some of the things here, and we'll see already the Git integration in VS Code is telling us that this line is blue. Blue means that that line is changed, and if you click on it, you can see what the change is. It'll show in red what used to be there, and in green what is gone now. So then if we add a new line here, it'll combine that with the previous change. You can see it's added a couple lines and removed one. If we go somewhere else further down, and say we add another paragraph here, then we can see that it's green because it's created something here. Nothing else was removed. And then if we go ahead and we remove stuff, then we'll be able to see this little red triangle showing that something was removed here. You can click on that to see that we removed that paragraph tag there. So now once you save this file, if you look over on the left-hand side of VS Code here, it'll show the changes. This is part of the Git integration with VS Code, which is incredibly useful and how I normally interact with Git. Just to show some other places where you can see that change, it'll also show up in the GitHub desktop app here, just like this. So then you can write a commit message here, and then also a description down below if you'd like, and then you could commit that way. We can also see Git Status from the command line, that there's been a file that's modified but not added, not staged. So then the way that I like to work with it is in VS Code here. So right now we can see there's changes here. If you click this plus, then what it does is it stages them, and that's the same as when we ran Git Add. So now if we run Git Status again, we can see that it's been modified and it's set to be committed. So now, up here, if we type in a commit message, we can say we customized app.js, and we click the check mark here, then it's going to commit that. So now if we look here and run git log, not that, git log, we'll see this commit right here. But if we look in the GitHub desktop, we'll see it in the history here. But then there's this arrow here, and it says push origin, and that means that we need to send the repository to GitHub. So if we look on GitHub right now, I think I called this web dev react. We can see the initial commit, the GitHub desktop app found and pushed now, but it doesn't have the commit from just a minute ago of when we changed app.js. So what we need to do is push this commit to the remote. You can do that any number of ways. You can type git push on the command line here. You can go here and click push origin, or even just from straight in VS Code, you can click this button right here. You can see the 0 next to the down arrow and the 1 next to the up arrow. So the 1 means we have one commit locally that is not pushed to the remote, and we have 0 commits on the remote that we haven't pulled in locally. So I'll show you what that looks like here. So first we're going to push this just by clicking that button, and it'll send it to the remote. And if we refresh here, we'll see 1 minute ago we customized app.js. So now when you're collaborating with other people, then they'll be able to get those changes too. But for them, it's going to say that there's a change to be pulled. So to simulate that, we're just going to make a change here on the web, modifying this file. So we'll make this change here. We'll just say update app.js. That's the default. We'll keep that message. So now we can see that the most recent commit was update app.js now. And if we go back to GitHub desktop and VS Code, we'll see that it doesn't update right away because it only runs what's known as a Git Fetch every so often. So we'll run that here from the command line, and that way it's going to find out what's happened on the remote since it last checked. So now, if we look at any of these, we can see that there's one commit from the remote that we can pull in. So this is what you would see if you're working on a project with someone and they've made a commit and you haven't pulled it yet. So then we pull this, and we'll see that it updates the file right away with those changes. So this is one of the things that makes Git so useful, is the ability to track the changes between files on a whole repository, a whole code base, and let people collaborate on it in real time by having them commit those changes, send them to a remote repository, and then pull them for other people. That's one of the big reasons people use something like GitHub instead of just using Git on its own, is the ability to send the changes you've made somewhere else and have other people find them. However, that doesn't come without its issues, because when you're working on a file and someone else is working on a file, then what might happen is you've both changed something in that file and Git doesn't know what to do with it. So let's delete that paragraph tag here and commit that. And this time we're not going to push right away. Instead, we're going to go back to the web and we're going to make a different change here. And so now, once we've committed this, then what's going to happen is there's going to be two changes to the same part of the code, and Git isn't going to pretend to know what to do with it. It's going to ask you. So we can see here, there's now a merge conflict. This is by far the scariest part of working with Git, but once you know what you're looking at, it's fairly manageable. So what it does is it adds a little bit of syntactic text to the repository in all the places, in all the files where there was a conflict. To start, it's going to have this leftward pointing angle brackets, and then head. And it's going to separate in between that and this equal separator line. It's going to have everything that was in that part of the file that was in the head, which is the term for basically the most recent commit on the local repository. And then after the equal sign, it's going to have all the code from this commit. And so this is the, okay, so I think what's happened here, this is the hash of the commit. Every commit in Git gets a unique hexadecimal hash so that they're all identifiable and all unique, that kind of thing. So if we go to the code here and click on commits, we can see all the different commits which have their names, but they also have these hashes next to them, which are a good way to uniquely identify a commit, especially when you have two commits, one after the other, that have the same exact commit message. So if we go back to VS Code here, we can see that it does give us some options for what we want to do. If you accept current, then it's just going to take everything in between these two tags and make that what it keeps. Incoming does the same, but it only keeps this part. Both means it's going to keep everything. And then if you click compare changes, it'll open up this compare here, which does a nice job of showing you what those differences actually are. The same thing happens if you go into I thought it showed it nicer here. I guess it doesn't. But in VS Code, it shows this comparison here, which is a great way to tell what's changed and what hasn't. So then you can choose to click on either of these. You could also just choose to modify it by hand if you're confident you know what you're doing. Just remove these tags, because that's the only way that Git knows that there is a merge conflict. But for here, we'll just click accept incoming. We'll save the file, and then we'll just stage it and commit it. And so now that makes a merge commit, which we can then see here. If we do git log again, we'll see that there was the remove paragraph commit that we did locally, and then the update app.js commit that we did on the repository. And then we can see there's a merge commit here, merging them together. And then we'll push that to the remote, and we'll be able to see those changes here. So that's not the only time you'll do a merge. The other time you'll do a merge is if you have a pull request, which is a feature in GitHub and a lot of other Git centralized repository systems. But to go over what a pull request entails, we probably should talk about branches first. So a branch is a concept in Git that basically means if you're working on these files, then just sort of keep them a little bit separate from other commits that other people are working on, or that even you are working on. So to create a new branch, just click on the master down here in the bottom, and then we'll type a new branch name. So let's call this Owen, and we'll click create new branch. And so now we're going to be on the branch Owen, and it'll show this icon here, meaning that the remote doesn't have this on it. So if you click this, it'll push this branch to the remote. So we'll do that here. And then we can add more code and save it here and commit that. So now that we've made that commit here and pushed it, if we go to the remote and refresh, we won't have any of that change here on the master branch, because it's instead going to be on the Owen branch. And then we can see the commit from 14 seconds ago on this branch. And you can see that GitHub is already suggesting, hey, it looks like you pushed something pretty recently. Maybe you want to merge that into master. So ultimately, the goal of most branches is to be merged into whatever the primary branch is. In this case, it's master. And so you can do that either with a pull request or just through Git on its own. I'll show the Git way of doing it first. I think there is a way to do this in VS Code. You can click merge branch. So that does the merge, but it doesn't give a great menu for it or explain what it's really doing. It's more or less the same as doing it on the command line, typing git merge and doing it that way. So I'll just go over it on the command line then. So what it does when you run git merge is whatever your local branch is. So if we run git branch here, it'll show the list of branches and it'll highlight the one we're currently on. So then what you want to do is run git merge and then type the name of the branch that you want to merge into the current branch. So right now we have some commits on Owen and nothing really on master that we would want to worry about. So let's give us something to worry about and go back to master. You can change branches just by clicking here and then changing it. And then we'll add a new tag and we'll take that and we'll commit it. And so one of the nice things about Git is before we saw there was a merge conflict when we modified the same part of the paragraph, or the same part of the file, that is. But a lot of the time, Git is smart enough to know that something you worked on doesn't need to be a merge conflict if it doesn't conflict with a different part of the file or anything, which can be good and bad, but it's usually good in my experience. So now if we switch back to Owen, we'll see that code isn't there anymore because it's going back to the state it was on the last commit to the Owen branch. So we run git merge master now, then there won't be any merge conflict, even though they both had two commits that weren't on the same branch. We'll see that it's just added this paragraph here from our other branch and is totally happy, no complaints. There's two commits to merge. So now if we push that, then we'll again be able to go see here that there are changes on no changes on the master branch, but there are changes on the Owen branch. So that's how you run a merge locally. So now we'll show what a pull request looks like on GitHub. So this is, for example, how you would request your changes be merged into the master branch of a repository that you might not be the owner of. For example, the WebDev website repository, you'll need to open a pull request from your branch to the master branch and then have it approved by someone to get it merged in. So now we'll just give this pull request a name. So we'll call this Owen's PR for pull request and create that. So then what it does is it groups up all of these commits into one sort of large commit that you're requesting to be pulled into the main code base. So if we look at the commits here, we can see the list of them. And a great way to look at it is just click on Files Changed, and you can see the sum total of all the different changes from every commit. And then if you go back here, you'll be able to discuss it, comment on it. Other people can go in and review it. So I could say request like Bailey review it if he was on this repository. And then once you've decided that everything looks good, this is what I want to do, I want to merge this, then you can click Merge Pull Request, and it'll create that merge and change to say merge to show that it's done. So now if we go back to the code, we can see it has the merge branch master into Owen, which is what we did locally here as the most recent commit, which matches what we have locally. And then if we go back to VS Code, Owen's going to be up to date, but if we go to master, then we'll see that we are going to end up being, so right now it says there's 1 to push, but now it's just about in, now there's 3 to pull. So there was the 1 commit on master that we then merged into Owen that then had some more commits added, and then it got merged back into master. So now origin master is ahead of here. Now we'll pull it down to make them all match. So now a lot of that sounds complicated, and especially if you don't have a mental model of what a GitHub tree sort of, or a Git tree looks like in your head. But one thing that GitHub does that's really nice is if you go to settings here and click on branches, or is it under, where is it? Oh, it's under insights now, I think, actually. Yeah, if you go to insights and you click on, or I can never remember if it's network or forks. Here's it is, network. So network shows the commits of the repository on all the separate branches and how they all got merged into each other. So you can see here, this change was the one that we made locally compared to, or this was the one we made locally compared to this one online, and then they got merged together. We made a few different commits and merged them all together, and then we pushed it all, and so now this is where everything is. And you can see it points to the different commits where each branch is pointing right now. Um, not to get too into the weeds, but a branch is technically just a different name for a tag, which is something that Git has in it to just apply metadata to a commit, so to speak. So head, for example, is also pointing to master right here, because head is the most recent commit on the given branch. So then you'll see Owen points here and master points here and that kind of thing. Unfortunately, there isn't a great way to get that sort of data on the desktop app without having pushed it. And you also aren't given access to this feature on a private repository. It's only available on public repositories unless you have a premium subscription, I think. But one tool that I use that I really like that does have that and a lot of the other same features as GitHub Desktop is called Sourcetree. It's a application it's a Git graphical user interface made by Atlassian, the same people who make Jira and other tools like that. So you can download that. I don't know if I actually have it installed on here. Does not look like it. But what it does is it shows the list of commits with that graph next to it, showing where everything is. And you can see things like master, and then origin master, which is master on the remote. Same with origin head, and then the different branches as well. And it is a great way to visualize what your repository sort of structure is based on all those different commits. So I use this a lot in determining what the most recent commits were on my branch. It's also very convenient if you're trying to debug an issue, figure out what commit it got introduced in. You can just double click on a commit and it'll check it out, and then you can test and see if the bug is still present and that kind of thing. So I find that it's really helpful. It has all the similar features that GitHub Desktop does for showing you the history, showing you the changes on a given commit, that kind of thing. And it's totally free to use. So I would definitely recommend using this if you are looking for an all-encompassing GUI for using Git. I think a lot of people can probably get by just with using the Git features integrated into VS Code and then using the features on GitHub itself. But personally, I find that having something like this locally is very convenient. We've gone over a lot of stuff since the last pause, so has anybody got any questions at this point?
I have a question.
Yeah, go ahead.
So, what if you are looking at your repository that you're working on with a few other people and you're like, wow, that's a really bad function? How would I find out who wrote that?
Sure, so you want to know who is at fault for writing some piece of code? That is something that
Exactly.
I can see you doing that, Ryan. So Git comes with a feature called Git Blame, which is exactly as the name implies. You can get the blame for a certain file or line of code. You can use it from the command line like this, and you can see all the different options. And to be honest, I really don't know exactly how to parse this, how to get the right results out of it that you want in a nice way. Instead, there's a VS Code extension. I'm not sure if I have it here on this device, but it's called Git Lens. And so what it does is it adds even more Git features to VS Code. And I know Ryan's asking this because I showed him how to install this a couple weeks ago. So what it does is it gives you, like it says, you can visualize code authorship, which is more or less what Git Blame does. So if we have that installed now and we look at a file, up in the top right, there will be this Git Lens. And it'll also put this little message after the code in a file here. So it'll say 19 minutes ago, and then the name of the commit, and then it puts this little additional box on top of code if you hover over it, showing what the commit was, what the change was, that kind of thing, and who made it. You can also toggle file blame and have it all show up on the left here. So this is a good way to separate a file out by commit, by author, that kind of thing, to tell when a change might have happened. And like Ryan said, figure out who might have written a particularly ugly function. In my experience, in about 90% of all cases, if I'm looking at code that I think is ugly, I'll take a look and I'll find out that I wrote it. So it's always a good humility check in that regard. So we can turn that off. You can also toggle the heat map to show which parts of the file get changed the most, or the file changes to see just what changes happened most recently, I think. I don't really use those ones as much, but the file blame is helpful for if you're looking at a file that's unfamiliar to you, you can figure out who's worked on it recently that you might be able to ask for some guidance, who knows more about that file and that part of a repository, that kind of thing.
It also very usefully tells you how long ago it was written too. So like if you see that it was last updated 3 years ago, you know that it's something that people have not actively been looking into.
Or that it works really, really well.
Yeah, or that.
Yeah, so that's another good extension to install there. Anybody else have any questions at this point? All right. Then in that case, I think we've covered most of the important features of Git and GitHub, how to use them from the command line, from the GitHub desktop application, and from VS Code, and some of the different techniques you can use to collaborate with your team. The last thing I'm going to leave you with is an article that I learned Git from. It's called Git Flow, and this is more or less the Git methodology, way of structuring branches and merges and that kind of thing that I personally subscribe to, that I use in most of my projects, and I think is a reliable way to keep your code organized and not too cluttered. It's not too long. It's a pretty light read and it's very approachable, but I don't want to plagiarize this article and just read it out loud to you. So I'll send a link to that in the meetings channel right now so that you can all go find that and read it. But apart from that, I think that that's everything that I think will be beneficial to you as you start learning Git and using it to collaborate. Thanks everybody for coming tonight.
Thanks, Owen.